Now we know quite a lot about the way weather is formed, but how do we actually receive this information and analyse it to understand if it's a safe day to go flying? Let's find out. Hi, I'm Grant and welcome to the 17th and final class in the meteorology series. Today we're going to be taking a look at aviation-specific meteorological reports. There's quite a few out there, but they all share fairly similar characteristics. So hopefully by the end of the class, you'll be able to break them down, analyse them and extract the important information that you need. METARs, or Meteorological Aerodrome Reports, provide information of the actual conditions currently happening at an aerodrome, and they're usually issued every 30 minutes. This is what one looks like, and yes, it looks a bit intimidating and complicated. There's a lot going on here, but thankfully though, it's always in the same order, so each section can be broken down and tackled separately. METARs are the foundation of these weather reports, and a lot of other reports use very similar format with the same sort of codes. So the first section is the type of report. We can see it's a METAR. Then we have the aerodrome's ICAO identifier code, which in this case is Palma de Mallorca in Spain. Next we have the date and time. So this is the 14th of the month at 12:50 Zulu. We don't need a month designator or a year designator, we just need the day. And it's always in Zulu/UTC time. Then we have the wind section. So in this case, it's a wind of 320 degrees at 12 knots, gusting up to 20 knots. In written formats such as METARs, the wind is given in the true direction. In Europe, where variation is small, it makes very little difference, but in some places you can get large differences between magnetic direction and true direction, and very usefully, runways are stated in magnetic direction, so you will need to use the variation of the airport to convert between the two. Next up you have visibility, which in this case is 9999, and it's in meters. There's only 4 digits it's given, so 9999 means there's 10 kilometers or more of visibility. Next up you would have weather information. In this example that I've used, there's no weather phenomena, so there's nothing in here, but you might see something like RA for rain, for example. Next, you have clouds, and it's cloud coverage given in octas. So few is 1 to 2, and the altitude is 2,500 feet above the aerodrome. There will either be few, scattered, broken, or overcast, and then it's the altitude over the aerodrome. Next up, you have the temperature and the dew point in degrees Celsius. In fog, these numbers would likely be the same, so it's worth keeping an eye on the temperature and dew point, as if they're very close together, there's a good chance that fog might be on the way. Then we have the pressure setting, the QNH, that when set will indicate the aerodrome elevation. In our case, it's 1021. After that, we see any recent weather that might have happened. RE standing for recent and RA standing for rain. So that would mean that within the past hour, it's always within the past hour, it has rained. We then might see a little WS, this might not be here or it might be here, to indicate if there's any wind shear. And then we see any trends over the weather for the next 2-hour period. It's basically a small forecast, and it can describe anything like wind, cloud, or visibility. But for our example, it says no SIG, which means no significant change. So there's various codes for the weather, such as the RA for rain, or a DZ for drizzle, or a SN for snow. There's basically too many to list, and there's some that are quite obscure, such as PO for dust devils, which are caused by dry wind over deserts. But generally, by looking at weather reports and using a METAR decoder, just have a quick Google and you'll find one, then you will be able to build your familiarity with the codes and what they mean. You see some that are quite common and significant, like BR is for fog, you want to know about any fog, and also TS for thunderstorms, you want to know about any thunderstorms. It's just a case of practice and repetition. If there's any significant change to the weather that occurs in between the normal 30-minute cycle of METARs, then airports might issue a SPECI, an SPECI. It's basically a special METAR, and it's exactly the same format as this, but it will start with SPECI in here to indicate it is outside of the normal 30-minute cycle. A terminal aerodrome forecast is a forecast of the conditions at the aerodrome that are expected. Commonly, they have a time frame of 24 hours, with a new one being issued every 6 hours to update the forecast as we go through the day. You can also get ones that are 9 hours, issued every 3 hours, or ones that are 30 hours long. You just have to basically look at the time frame, which is indicated here, to figure out how long the TAF is valid for. They're very similar to METARs, and you will see a very similar format. So in this example, we see the prefix at the start. In this case, it's a TAF. We then see the aerodrome 4-letter identifier code, just like in the METAR, in this case LECB, which is Barcelona. We then see the date and the time that this TAF was issued. In this case, it was on the 14th at 10 Zulu in the morning. Up to now, exactly the same format as the METAR, but after the first time follows one of the first major differences. So as this is a forecast, we talked about it earlier, we have to know what period it covers. In this case, it's from the 14th at 10 a.m. to the 15th at 10 a.m. So it's a 24-hour period. And after this initial line follows the forecast for the day with any further changes with some key exclusions from it. Namely, there's no temperature or dew point predictions, Q&A predictions, or recent weather or wind shear predictions. So we can see the weather here is predicted to be, in this 24-hour period, a wind of 250 at 12 knots, visibility of at least 10 kilometers or more, and we're expecting few 1 to 2 octaves worth of clouds at 2,000 feet above the aerodrome. And then you see a few different leading codes which are given in front of some other weather. The key code could be FM, which indicates a rapid change at a specified time. It could be becoming, BCMG, which means a gradual change between two specified times, or it could be tempo, which means temporarily in between the period that it states, the weather will be that condition, and temporarily means less than an hour. You might also see prob 30 or prob 40, which indicates a percentage likelihood of the conditions happening. So in our TAF here, we can see that after the initial conditions, the clouds are becoming slow gradual change on the 14th between 2 and 3 in the afternoon. There's going to be a gradual change towards scattered 3 to 4 octaves worth of clouds at 2,000 feet, and the type of clouds are going to be towering cumulus, which are the precursor to cumulonimbus and thunderstorms. Then we have a 40% chance that for less than an hour between 4 o'clock and 6 o'clock, there will be thunderstorms and rain. So we see the precluder and the thunderstorms and rain themselves. Then from 6 o'clock on the 14th, everything's going to die down a bit. We're going to get back to variable 2-knot wind with few 1 to 2 octaves worth of clouds at 1,800 feet above the aerodrome. And then there's nothing more. So we assume that the weather conditions are going to stay like this until the end of our period in here. With this information, and say we have a flight that's arriving at 1700 hours, it might be a good idea to take extra fuel with us, just in case there is a thunderstorm overhead Barcelona at the time we arrive. Because if we take extra fuel, we can hopefully wait for this storm to pass and land safely before having to divert somewhere else. A SIGMET, or Significant Meteorological Information report, is another weather report which is all about weather events and phenomena that might impact flight safety, such as thunderstorms, hail, severe turbulence, freezing rain, mountain waves, and tropical revolving storms. They are issued by specific Met offices and when they're needed, basically, and they're valid for about 4 hours. They are similar in format, once again, to METAR and TAFs. It starts with an identifier code, in this case LHCC, and this refers to a region rather than an airport, something that's known as a flight information region. You get them spread out over countries. Some countries will just have one, some countries will have a couple, and basically they collate information for en route rather than airport stuff. So in this case, the region is Hungary, LHCC. Then follows the SIGMET prefix. The SIGMET itself will have an identifier code. It'll have Tango 04 in this case, so that when air traffic control speak to you, they go, are you aware of the Tango 04 SIGMET, you could say, yes, I know what's happening. Then we have a time frame, so it's valid on the 1st at 04:30 in the morning to the 1st at 05:30 in the morning. So it's only an hour-long period, first thing in the morning. All weather reports seem to start this way. Who's talking to you, what type of report it is, there might be an ID code, and then sort of time frame before it gets into the weather itself. So that's the SIGMET identifier section, and then we get into the actual weather report itself. So again, we've got the region, it's Hungary. It's more specifically the Budapest FIR. I can't remember if Hungary is split into multiple, I don't think it is, but it's the LHCC Budapest FIR, that flight information region. And what the weather report is we've got embedded thunderstorms forecast within, and then there's a whole bunch of coordinates in here. If you have a map, you could then draw this area out on your map, and we can see that within that region there's going to be embedded thunderstorms. We know that the tops will be at flight level 300, it's moving northeast, and it's generally weakening over time. Again, the specific codes will just come with practice, but in a SIGMET it's always going to be something that's a bit nasty, like TURB for turbulence, TURB, or GR for hail, SEV for severe, or in the worst case you can get RDOACT CLD, which is a radioactive cloud, which hopefully nobody ever sees. A significant weather chart shows information normally in a SIGMET, but in probably a more useful format on a map, along with information about any jet streams. There are various symbols that again come with practice and repetition. This is an example of a flight that I did a while ago on the 8th of August from Lanzarote to Edinburgh in the UK. Some of the symbols of note are icing, which is given this symbol here. It's quite small there, so it's sort of a semicircle with two lines. That's icing. And you get turbulence, which is this symbol here. It's a straight line with a bump and then another line. You'll get used to these symbols as you just look at more of these significant weather charts. And you get other symbols like these solid black lines are jet streams, along with the speed of the jet streams themselves. And then you get CBs standing for cumulonimbus clouds, think thunderstorms, and it'll be the top level, and the XXX means it's off the bottom of the chart. Where is the bottom of this chart? We can see that this one goes up to flight level 100 to 450. So this is a cloud that extends from below flight level 100 up to 300. There's a few of them embedded in this area of other clouds, and yeah, might be worth avoiding that area if you're flying towards it. You also get these spot levels here, which is the height of the tropopause. So on wind charts, you get a chart that shows the wind, unsurprisingly, and also a few temperatures along our route. They're quite easy to understand if you understand the concept of the wind arrow. So think of it like an arrow from a bow, and the feather at the back of the arrow is these lines, and that indicates the strength. A triangle indicates 50 knots, a full line is 10 knots, and a half line is 5, so you just add them together. So if we pick a random one, maybe this one at ADVAT, we can see that the strength of this wind is about 35 knots, and it's blowing from the southwest. We can also see the general pattern of wind along our route is westerly, changing towards northerly as we reach the UK. So the weather reports we've looked at so far are what we'd look at when we're on the ground planning our flight. But when we're in the air, we don't have access to the internet to look up new METARs for the aerodromes when we're flying around. So we use something called volmets and ATIS. Vol means flight in French, and met means for meteorology. So you get a volmet, in-flight met reports. And basically this is a frequency that you can tune into, and it broadcasts METARs and TAFs in plain language for airports within a specific flight information region. I could tune into London South's volmet on whatever frequency it is and listen to the METARs for a range of airports in London FIR, always in the same order. Occasionally, very frustrating, you'll just miss the airport. Say I wanted, I don't know, Birmingham, and I heard Cardiff was on the radio just as I tuned in. I know I've got to wait through all these before eventually I get back to Birmingham. For a more specific report, you would tune into the ATIS. This is an automatic terminal information service, and it's a more local version of the VolMet that is airport specific. Every major airport will have a frequency you can tune into and receive weather information about an aerodrome, including any operational information about the airport, such as runway and type of approach in use. It also contains something called a runway condition code. This is a code used to describe if there's anything on the runway like water or snow, any contaminants on the runway. And depending on the type and depth of contamination, it's given a rating from 1 to 6 for each third of the runway. A dry runway, for example, is given 6, 6, 6. Something very specific that you get into in operational procedures. So I'm not going to cover it now because depending on the depth and the type, it makes it a whole thing. So when you listen to an ATIS, it's very local information, and the wind direction is given in magnetic direction, in contrast to the METAR, which gives true direction. I always remember it as if it's written, it's true, the 2 T's and true. Some airports might have a digital ATIS system, which sends aircraft direct text forms of ATIS, which does make this memory trick a little bit confusing. But think about it, if it's normally written, it's true, or if it's listened to, it's magnetic. So an ATIS itself might sound something like this. Gatwick Information Romeo issued at time 0930, runway news 26 left, 666, expect an ILS approach. Wind 250 degrees at 7 knots, CAV OK, which means cloud and visibility OK, meaning cloud above 5,000 feet and visibility more than 10 kilometers. Temperatures 26, dew point 13, QNH 1012, on first contact report information Romeo. Although normally in a very digital robotic computer voice, Gatwick Information Romeo issued at time, it's very boring like that. And at the start you might have noticed it says Information Romeo. What we do is when we speak to air traffic control for that airport, we tell them that we've received Information Romeo and we're all up to date with the weather conditions at the airport by saying something like, hello Gatwick, flight Alpha Tango Papa Lima at flight level 80, heading 360 degrees with Information Romeo. Then they know who we are, where we are, and what we know about where we're going. So instead of the classic summary like I normally do, I'm going to show you how I would analyze a weather report for that flight that I did from Lanzarote to Edinburgh a wee while ago, and hopefully there's a few things you can take from it which you find useful. So I can't remember what time this flight actually was, but let's see, it's looking quite valid. So 2 o'clock. Let's say we're leaving at 6 o'clock in the evening. Seems about reasonable. So I'd write that down first, and then I have the validity time that I'm looking for. And our scheduled time of arrival into Edinburgh was midnight, I don't know. Okay, so I've got 1800. I look at the METAR for 1800. That's about 01022. Runways, we've got 03 and 21. That wind is favouring runway 03. We've got good visibility, a few clouds, 26 degrees, 1015. Wind strong, but relatively straight down the runway. It's not going to be any crosswind to think of. For our period, we can expect maybe some 30% chance of no more than an hour of the wind going continuing this direction, 17 gusting 29. So that reflects what the weather is actually doing just now. So we're okay to depart Lanzarote without any issues. We've got a nice strong wind blowing in our head, helping us with any performance issues that we might have. In Edinburgh, we get back at midnight. This is current for now, so that's not going to be relevant, but we can see that between 6 and 6 on the 7th and the 8th, we've got this weather conditions, 250 at 12, which means it's going to be runway 24. Temporarily, it's going to change to broken up 1,200. 40% chance for an hour, that between 6 and 8, 8,000, light rain, broken 900. And then temporarily, well after we arrive at 3 a.m, broken 1,400. So we're not expecting this because that's finished by the time we arrive. We're expecting these conditions here. So 250 at 12, visibility 10 kilometers, broken clouds 2,500, runway 24. Then I can get those charts up, have a look, familiarize myself with the approaches, see what I need to do to get myself ready for this flight. We can also use the weather reports for any alternates. So we've got various alternates here. Our number one, our closest, would be Glasgow. And we're expecting to arrive, it'll be just after that. Let's call it 0020 or something like that. So again, it's going to be quite similar to Edinburgh because they're quite close. Let's see if that's true. We're looking at 250 between 6 and 6, that's fine. Until 10, few at 3,000, not significant. Less than an hour, between 6 and 9, 8,000, light rain, broken clouds 800. 40% chance after we arrive. Okay, so we're defaulting back to these conditions here. 250 at 9 knots, that's good wind for runway 23. 10 kilometers visibility, clouds 1,400 feet. So our departure, destination and alternate, all good weather, nothing to think about in terms of storms or visibility issues. Now turn over the page, look at something suitable en route. So Cork in Ireland seems to be suitable en route. We said we'd arrive back into Edinburgh about midnight. So let's call Cork at about, 10:30, something like that. So we can see between 6 and 6 on the date, it's this conditions. For not more than an hour until 9, it's going to be 3405, that's fine. And then it changes for an hour between 1 and 7 a.m, a bit of overnight fog. That's the BR, 3,000 meters visibility, reflects the fog. And then there's a 30% chance from 3. So that's all passed by the time we got on. So I'm not really interested in that. That's much later in the day. The thing that's important to us is we're seeing 210 at 10, 10 kilometers or more visibility, scatter clouds at 3,000. That is good for runway, what would that be, 16? Oh no, they got 0725. So runway 25, and it can be used. That's fine. And then you'd see any SIGMETs. So the Canaries region, no SIGMETs. Casablanca, no SIGMETs. Lisbon, no SIGMETs. 0, 0, all good. Then we would have a quick look at the significant weather chart. This is the one we looked at earlier. We've got a line. This is issued at 0600. So, that's the one I actually drew on earlier. So you can see nothing on our route. That's fine. But potentially this stuff will be blowing in, and we'll have a look at that if it passes our route. So this is the one previously, did it in the wrong order. Look at the time. It's previously, you can see that this stuff is moving in as it was predicted to be. And then we have the 1800 one, just as we're taking off. Again, this weather seems to be pretty stable over this region, but out of interest, we'd see that we've got some turbulence, some icing up to level 160. We're expecting to be above that. But if we were flying through this region, expecting a lot of jet stream activity, potential for some clear air turbulence, some strong winds, and any clear air turbulence is given a little dotted line and then a number. The numbers can be quite difficult to find sometimes. And then you reference it over here. So in 3, we were saying we were expecting some turbulence. Yep, that checks out. We've got some light turbulence between 380 and 260. And in section 4, wherever that is, 5, 4, I think that's this, a region that's off the map over here. We can see that we get occasional severe turbulence. That's when we get a extra line on top. That means severe turbulence. And that's what I would do. I'd look, see if there's any significant weather, look at the airports themselves, and yeah, generally just have a look at the weather information for your region. You might be able to get a METAR, aviation weather app or something like that. Just have a scan, familiarize yourself with any codes. use a METAR decoder if there's anything you're struggling with, and yeah, should be all good.